Okay, so here we go. This is using fundamental identities 5.1. So the first group, we are to use fundamental identities to find the remaining functions if possible. So we're given that the secant of theta is the square root of 2 and the sine is negative the square root of 2 over 2. So we have the reciprocal identities first. So the reciprocal of the secant is the cosine. So if we take the reciprocal of the square root of 2, we get 1 over the square root of 2, which then becomes the square root of 2 over 2, which looks familiar. And the sine of the secant and the cosine and the cosecant and the sine are always the same. So you have the sine of theta is, so if we need to find the cosecant, that's going to be the cosecant of theta is 1 over the sine of theta. So that's 1 over negative the square root of 2 over 2. So we can take the reciprocal of that. So it's negative 2 divided by the square root of 2. And if we multiply and divide by the square root of 2, we'll get negative 2 times the square root of 2 divided by 2, which is negative the square root of 2. Now, because the cosine is positive and the sine is going to be negative, so the cosine is, what do we say? The cosine is positive, so that's got to be the first or second quadrant. And the sine is negative, so that's going to put us into the fourth quadrant. So we know the tangent of theta has to be negative, and that works out because of the difference in signs here. So the fundamental identity we would use for calculating the tangent is the quotient identity. So we take the sine of theta, which is equal to, what did I just do here? This is actually the cosecant. Cosecant of theta is minus the square root of sine of theta. Okay, so you get the minus the square root of 2 over 2, which is the sine of theta. Here's the cosine of theta, which is the square root of 2 over 2, and they're the same except for the sine, so you get negative 1. And the cotangent of theta, this is a reciprocal identity, is 1 over the tangent of theta. So that's 1 divided by negative 1, which is negative 1. Okay, so that's the first problem. The second one, we have the cotangent is negative 3, so therefore the tangent is 1 over the cotangent, reciprocal identity. So it's negative 1/3. So we get negative 1/3 reciprocal is, negative 3, the reciprocal is negative 1/3. In terms of the quadrant, the tangent is negative, so the tangent's negative in the second and fourth quadrant, and the sine is positive, which is in the second quadrant. So we know that we're a second quadrant situation here. So I've got the tangent, the sine of theta. The sine is the square root of 10 over 10. So the cosecant of theta is 1 over the square root of 10 over 10, or 10 divided by the square root of 10. So when I divide 1 by a number, you take the reciprocal of that number. And then I multiply and divide by the square root of 10. So what I'll get is 10 times the square root of 10 over 10, or the square root of 10. Okay, so that's the cosecant. So I got the other two are cosine and secant. Now, because we're in the second quadrant, we know that the cosine is going to be negative. So one way of doing this is you could still use the quotient identity, but instead of solving for the tangent, if you solve for the cosine of theta would be equal to the sine of theta divided by the tangent of theta. So the cosine of theta is the sine of theta, which is square root of 10 over 10. And the tangent is, where's the tangent? The tangent's up here. It's negative 1/3. So you take the reciprocal of the denominator. So the reciprocal of negative 1/3 is negative 3. So we get negative 3 times the square root of 10 over 10. So that's the cosine. And so the secant is 1 over the cosine. So you can take the cosine, just flip everything over. So 10 divided by 3 times the square root of 10. Instead of the square root of 3 times the square root of 10 over 10, it's 10 over the square root of 3 times 10. And then you multiply and divide by the square root of 10. So you get negative 10 times the square root of 10 over 3 times the square root of 10. You see, actually not over the square root of 10, but over 10. Because the square root of 10 times the square root of 10 is 10. The 10's cancel out, and you get negative the square root of 10 over 3. Now if you think about what's going on here, you know, if we drew a triangle and theta was this angle, we could use one of these like the sine, opposite over hypotenuse. So then to find this third side, you'd say x squared plus the square root of 10 squared is equal to 10 squared. So you get x squared is equal to 100 minus 10, which is x squared is equal to 90. And that's equal to the, so x equals the square root of 90. That's equal to the square root of 9 times 10, or 3 times the square root of 10. So this side is 3 times the square root of 10. So if you look at all these things like the cosine, that's negative 3 square root of 10 over 10 divided by 10, and does that go along with what I got here? Yeah, this is, I don't know why I divided by 10 here. This is 3 times the square root of 10. So that's the length of the adjacent side. It's 3 times the square root of 10. So the cosine would be 3 square root of 10 over 10. 3 square root of 10 over 10. It's negative because of the quadrant, but you can see all the numbers make sense from a triangle standpoint. Now you don't need to do that. That was just to prove that I did it correctly. Okay, so the next one is the cosine of pi over 2 minus x equals 3/5. Now there's one of these, I forget what the heck they're called. Let's get my book out. Is it cofactors? Might be the word. Anyway, we're going to section 5.1 in the book, and right there, fundamental identities. So you can see that the cosine of pi over 2 minus x is the same as the sine of x. So the sine of x is 3/5, and then the cosine of x equals 4/5. Now, you know, what quadrant are we in? Well, they're both positive, so we're in the first quadrant. So that also means the tangent should be positive. So again, we can do the reciprocal identities. The cosecant of x is just the reciprocal of the sine. The secant of x is the reciprocal of the cosine. Then we can use the quotient identities. Cosine tangent of x is the sine of x divided by the cosine of x. The sine is 3/5, the cosine is 4/5, and that's the same as 3/5. Instead of dividing by 4/5, we multiply by 5/4. The 5's cancel out. You get 3/4. So that's the tangent. And this is one of these 3, 4, 5 triangles. You know, if the opposite side were 3, the hypotenuse is 5, and the adjacent is 4. This is the angle. So that's the triangle that would be associated with this particular thing. But the main thing is to use this called cofunction. This is a cofunction identity. To rewrite this in terms of sine, and then the rest of it's just like we did before. And then the final one, this tells us what quadrant we're in. So it's tangent is positive. So remember, all students take calculus. So the tangent is positive in the tangent's positive in the first and third quadrant, and the sine is less than 0 in the third and fourth quadrant, because of the sine of an angle is the y-coordinate, which is negative in the third and fourth. So you can see that this is a third quadrant situation. And that agrees with, you know, if they're both negative, if x and y are negative, then when you take y divided by x, you're going to get positive. Okay, so now what do we do? Okay, we've got the tangent, so always the easiest thing to do is to do the reciprocal identities. So if the tangent is 2, the cotangent is 1/2. What's next? Well, we could use this particular Pythagorean identity, because I know the tangent, so I can figure out what the secant is. And if I know what the secant is, I can find out what the cosine is. If I know what the cosine is, you can see what I'm doing here. So we're going to have 1 plus the tangent, which is 2 squared, is equal to secant squared of theta. So you add these together, you get 1 plus 4 is 5. 5 is equal to the secant squared of theta. Take the square root, you get the secant of theta is plus or minus the square root of 5. Now, is it plus or minus? Well, we're in the third quadrant. In the third quadrant, the cosine is negative. So we're going to say it's negative the square root of 5, because the cosine is negative, so therefore the secant is negative. And so then now that we know the secant, we can find the cosine. It's 1 over the secant. So it's negative 1 over the square root of 5. Multiply and divide by the square root of 5, you'll get negative the square root of 5 over 5. So that's the cosine. So we have the tangent, cotangent, secant, cosine. So now to find the sine, we could use the fact we know the tangent and the cosine, or we could use the we've done that before. Tangent of theta is sine of theta over cosine theta. So if we're trying to find the sine, so the sine is the tangent of theta times the cosine of theta. So the tangent's 2, the cosine is negative the square root of 5 over 5. So the sine is equal to negative 2 times the square root of 5 over 5. So we know in the third quadrant the sine's negative, so that makes sense. And then we could find the secant. I already have the secant. And you can find the cosecant. So the cosecant of theta is 1 over the sine of theta. So we get negative 5 divided by 2 times the square root of 5. Multiply and divide by the square root of 5. So you get negative 5 times the square root of 5 over 2 times 5. Square root of 5 times square root of 5 is 5. These 5's cancel out. And you're left with negative the square root of 5 over 2. So that's the cosecant. Now, we could also find the sine from using the Pythagorean identity that involves sine squared and cosine squared. So here is the cosine. So we know sine squared of theta plus cosine squared of theta equals 1. So we get sine squared of theta plus negative the square root of 5 over 5. That's the cosine of theta. Square that. That equals 1. Sine squared theta, the negative gets squared, so it becomes positive. And the square root of 5 squared is 5. 5 squared is 25. This is 1/5. Then if you subtract 1/5, you got 5/5 minus 1/5, so that's 4/5. Take the square root. Sine of theta equals plus or minus the square root of 4 divided by 5, which is plus or minus the square root of, well, square root of 4 is 2, so you get 2 divided by the square root of 5. If you multiply and divide by the square root of 5, you'll get 2 times the square root of 5 over 5. And because it's in the third quadrant, it's negative. And you'll see that should be the same thing that we got down here. The sine is negative 2 square root of 5 over 5. So there were 2 ways to solve that problem. Okay, so that was 4. I think that's all of them. Moving on to the next group. Match the trigonometric expressions with one of the following. So just basically what we need to do is take the 5, 6, 7, and 8. I don't know if there's a 9 and 10 here somewhere. 9 and 10. Yeah. So what we're going to do is we're going to use the trig identities to try to reduce them to something that we can pick out one of these solutions. So let's just. So the first one, secant times the cosine, but the cosine is 1 over the secant. So that's a reciprocal identity. So that's 1, and therefore 5 matches up with D. The next one is negative 1. Oh, that's the answer. Let's go to the next. Let's go to number 6. Tangent of x times the cosecant of x. Because there's nothing squared here, the best thing to do is to use the reciprocal identities and the quotient identities and see if we can cancel anything out. So we get the sine of x over the cosine of x for the tangent. The cosecant is 1 over the sine. So the sines cancel out. You're left with 1 over the cosine. And 1 over the cosine is the secant, which is a. So this one's a. So we can mark those out. So what do we have? This is 1. The first one was 1, so that's D. Okay, now we shouldn't even have to use process of elimination here. But okay, next one we got is cotangent squared of x minus cosecant squared. So because these are squared, it's most likely that one of the Pythagorean identities. So the one that involves cosecant and cotangent says that 1 plus the cotangent squared of x equals the cosecant squared of x. So I could substitute that into there. So the equation, first equation, becomes cotangent squared minus 1 plus cotangent squared x. So that's substituting for here. Cosecant squared is 1 minus cotangent. You can see the cotangents cancel out, and you're just left with negative 1, which is b. So this is b. Okay, number 8 is 1 minus cosine squared x times the cosecant of x. Again, this is a Pythagorean identity. If you look that up, you'll see that sine squared plus cosine squared equals 1. And so if you solve for sine squared, you'll get 1 minus cosine squared. So I can replace that with that. And then I can replace the cosecant with the reciprocal identity. So it's 1 over the sine. So sine squared divided by sine is just sine. So hopefully that's one of my choices. And we can go ahead and mark this one out because we just got that previously. So what we've got f. That's the sine. Okay. So we got 2 left. We'll work through them all. We're not going to just say, well, it has to be this because we run out of options. But okay, the next one is the sine of negative x divided by the cosine of negative x. So these are what are called odd-even identities. So if you go to there, page 354 in the 6th edition, you'll see the sine of negative x is going to be negative the sine of x. And the cosine of negative x is the cosine of x. So we get this negative sign on one of them and not on the other. And then the sine over the cosine is the tangent. So we get negative tangent of x. That looks like e. So that's good. And so our last one has to be the cotangent. So if we don't get the cotangent, we're going to be in trouble. So the next thing we do is we use these things called cofunction identities. And the sine of pi over 2 minus x is equal to, let's see, the sine of pi over 2 minus u. That's the cosine of u, but in this case we're using the variable x. And then we have the cosine of pi over 2 minus x. And that is, cosine of pi over 2 minus x is the sine of x. So we have the ratio of these two. We get that, and the cosine over the sine is the cotangent of x. And hopefully that's the one choice we have left, which it is. So that's C. So that worked out good. Okay. Okay, the next, use the fundamental identities to simplify the expression. There is more than one correct answer. So the first one, again, is there's no squareds. So probably using either the reciprocal identity or the quotient identity. Well, this is already cosine, so I'm probably not going to rewrite that. The tangent is the sine divided by the cosine. So these cancel out, and you're just left with the sine. I don't think there's only one way to do that. The next one's true as well, so you get 1 over the sine is the cosecant. The secant is 1 over the cosine. So here you have 1 over the sine, and you take the reciprocal of the denominator and multiply it. So we get the cosine of theta over the sine of theta, which is, from the quotient identity, the cotangent of theta. Okay, number 13, similar kind of deal. The secant is 1 over the cosine. The sine is just the sine. The tangent is the sine divided by the cosine. And you see those cancel out and those cancel out. And so all we have left is 1. So that's the simplification. The next one, it does have a squared, so that's one of the Pythagorean identities. And the one that involves the tangent. 1 plus tangent squared equals secant squared. So that's the identity. So what I've got here is 1 minus tangent theta squared. So that is interesting. So what can I do there? Well, if I solve for tangent squared of x, that's secant squared of x minus 1. And first thing I'm going to do is I'm going to check to make sure that is the actual problem that I should be solving, because I could have written something down wrong. So I'm trying to figure out where it is here. What's the wording on this thing? Use fundamental identities to simplify the, okay, that one. Cosine of, I think it should be plus. I'm just going to pause for a second. Okay, so yeah, it actually was plus. So 1 plus tangent is that. So then I can just substitute in for 1 plus tangent of theta. So I'll have cosine of theta times secant squared of theta. So cosine stays the same. 1 plus tangent squared becomes secant squared. But the cosine is 1 over the secant, so I could rewrite cosine of theta as 1 over secant, and then secant squared divided by secant is just secant. So that's the answer for this one right here, number 14. And then finally we have sine of theta times the secant of theta plus the cosine of theta times the cosecant of theta. So what we do is we would write the sine, and then the secant is 1 over the cosine, and then we'd have the cosine divided by the sine. Cosecant is 1 over the sine. Okay. Now let's find a common denominator. So if you do that, the common denominator will be sine theta times cosine theta. So it's kind of like you cross multiply. So you get sine squared theta plus cosine squared theta. So that you get sine times sine, sine squared, cosine times cosine, divided by sine theta cosine theta. But sine squared plus cosine squared is 1, so the numerator becomes 1. And then finally you would take the reciprocal of these. So the reciprocal of the sine is the cosecant, and the reciprocal of the cosine is the secant. So that would be your final answer, cosecant times secant. Okay, so that's it for that section. Factor the expressions and use the fundamental identities to simplify. There is more than one correct form of each answer. Okay, so you can see here I have a sine squared and a sine squared, so I can factor out the sine squared. So what that leaves is secant squared x minus 1. So I have this something squared plus or minus something. So this is probably using one of those Pythagorean identities, and it's the one involving the secant. So let me go back to the first page of this section. I've got 1 plus tangent squared of x is equal to secant squared of x. So if I subtract tangent, or subtract 1 for both sides, I'll get secant squared minus 1, which is what I have there. So now I can plug that into here like that, and you could leave it as such. You could also rewrite the tangent as the sine over the cosine. So the tangent squared is sine squared over cosine squared, and you'd end up with the sine to the 4th over cosine squared. So I don't know, 6 one, half a dozen the other. As far as which ways, that's why they said there's more than one way. The next one, this is kind of like x squared plus x plus 1. And then you would factor that. The issue is that I'm looking at that and you can't factor that easily. So again, I'm going to check to make sure I copied this problem down correctly. So where is this? So it's on, oh, that's because again I wrote it down wrong. So this is 2. So that'd be like x squared plus 2x plus 1. So the way you factor this is you'd have tangent squared of x as the first term. And then you have plus 1 here and plus 1 there. And the reason I'm using plus instead of minus is because I've got a plus 2 here. You can see that that works out. So tangent squared times tangent squared is tangent to the fourth. 1 tangent squared plus another tangent squared equals 2 tangent squared, and 1 times 1 is 1. Now this is using this identity up here. 1 plus tangent squared equals secant squared. So the first one becomes secant squared. The second one becomes secant squared. And secant squared times secant squared is secant to the fourth of x. So that would be your answer. And then 18, same kind of deal. This is kind of like x squared, x to the fourth minus 1. So you could break that up into x squared minus 1 and x squared plus 1. So you do the alternating signs so that the middle thing cancels out. So the corresponding thing here would be secant squared x minus tangent squared x times secant squared x plus tangent squared x. So again, using the same identity here, if we get what we're looking for is secant minus tangent. So if I subtract tangent squared from both sides, I'll get 1 is equal to secant squared minus tangent squared. So this thing becomes 1, and this other thing doesn't change. There's no way to simplify that. So you're just left with secant squared x plus tangent squared x as your final solution. Okay, next one is perform the addition or subtraction and use fundamental identities to simplify. There's more than one correct form of each equation. So here you're trying to find a common denominator. So here you would have the common denominator in 19 would be secant x plus 1 and secant x minus 1. So it's the two denominators. And then the numerator, you do this kind of cross multiplication. So you'd have the second denominator, which is multiplied by positive 1, and you'd have the second denominator, first denominator, which is multiplied by negative 1. So you can see how the secants cancel out in the numerator, and you have negative 1 minus 1. So the numerator becomes negative 2. And in the denominator you have secant, if you multiply this out now, so these are separate denominators, but when you multiply them together you can just FOIL, and you'll end up with secant squared, secant times secant, secant squared. The inner and outer cancel out, and you get secant squared minus 1. But again, you go back to this Pythagorean identity, 1 plus tangent squared of x equals secant squared of x. Or if you subtract 1 from both sides, you'll get secant squared x minus 1. So that's the substitution that I'm going to use there. So the numerator stays the same. The denominator becomes tangent squared of x. And then you can use the reciprocal, so you'll get -2 times the cotangent squared of x. So the reciprocal of the tangent is the cotangent. So that's how that one works. So that's the first one. Second one, same thing. One's a fraction, one's not a fraction. So you're going to multiply the first expression by tangent, both in the numerator and the denominator. The second term we're just leaving the same, but now you'll see that they have the same denominator. So we can combine the numerators, and the denominator is this tangent of x. Now up here, again, this Pythagorean identity, tangent squared minus secant squared. So if you have tangent squared, take this to the other side, it's minus secant squared. So this numerator is -1, and then you divide by the tangent, and the tangent is 1 over the tangent is the cotangent. So you get the cotangent of x. So this whole thing here simplifies down. Use the graphing utility to determine which of the 6 trigonometric functions is equal to the expression. Verify your answer algebraically. So we're going to do the algebraic part first. I guess we can plot it, and if it's not, then we don't have to verify it. So how do you verify something like this? Well, you plot it. And if it looks like anything we've seen before, then you can say it is. And then we can. So actually, I'm going to plot it first. So you got secant of x times cosecant of x minus tangent of x. And let's see what it looks like. So it looks like that. So it's not the sine or cosine, it's cosecant or cosecant. It's either the tangent or the cotangent. And the tangent goes from left to right this way. So it's got to be the cotangent. And remember, the cotangent is 1 over the tangent. The tangent of 0 is 0, so the cotangent of 0 should be 1 over 0, which is going to be infinity. So it's going to be divided by 0. So it's the asymptote is in the right place. So based on looking at the graph, this should be equal to the cotangent. So let's see if we can prove that's true. So 21 secant x cosecant x minus tangent x. So the secant is 1 over the cosine, and the cosecant is 1 over the sine. And I should be using x because that's a variable they gave us here. Minus tangent x. So what we have is 1 over the cosine of x, sine of x, minus tangent of x. So this looks like previously where we want to find a common denominator. So we'll have 1 over the cosine of x, sine of x, minus the tangent of x times the cosine of x. Cosine of x, sine of x, all divided by the cosine of x, sine of x. The other thing that, well, that's probably more than we, that's true, but I think there's one easier way. So if we rewrite the tangent as the sine of x divided by the cosine of x, you see I've got cosine in both of them now. So what I would do then is I could multiply this by the sine of x divided by the cosine of x. So now, multiply and divide by the sine of x. So in the numerator we get 1 minus sine squared of x divided by cosine of x sine of x. It's like a Pythagorean identity. Sine squared x plus cosine squared x equals 1. So if we subtract sine squared from both sides, we'll get cosine squared equals 1 minus sine squared. So the numerator is cosine squared, and the denominator is still cosine x sine x. And you see the cosines cancel out, so we're left with one cosine in the numerator and the sine in the denominator, and the cosine over the sine is the cotangent, and that's what we were expecting. Okay, next one is 22. So we get 1/2 times 1 plus sine of theta over cosine of theta plus the cosine of theta over 1 plus sine of theta. Okay, so again, this looks like finding a common denominator. So let's do that. So you get 1/2. So we're going to multiply this first term by 1 plus the sine of theta, which is the second denominator. And we're going to do that in both the numerator and the denominator. So that's the first term. We're going to multiply and divide by the second denominator. And then we're going to take the second term, which is the cosine of theta, and we're going to multiply by the first denominator, cosine of theta, divided by the, so we have this original denominator multiplied by the cosine of theta. So we multiply and divide by the cosine of theta, and you'll see we have the same denominator. Okay, so in the numerator here we're going to have 1, and you've got sine of theta times sine of theta. That gives you plus 2 sine of theta. That's the inner and outer, plus sine squared of theta. And then the second numerator is cosine squared of theta. And that's all divided by the cosine of theta times 1 plus sine of theta. Okay, so this part here is equal to 1 because sine squared plus cosine squared is 1. So we get 1/2 times 1 plus 2 sine theta plus 1, all divided by cosine of theta times 1 plus sine theta. Now I'll combine the two constants, so I'll get 2 plus 2 sine theta divided by the cosine of theta times 1 plus sine theta. But I can factor out a 2, so I'll get 1/2 times 2 times 1 plus sine theta. And in the denominator I have cosine of theta, 1 plus sine theta. You see that I've got 1 plus sine theta in both the numerator and the denominator, and those 2's cancel out. So I'm left with 1 over the cosine of theta, which is equal to the secant of theta. So that's what I should see. If I plot this function here, I should see what looks like the secant. And remember, the secant is 1 over the cosine, so you're going to have something kind of looks like that, and it's going to come down and go that way. Okay, so we have 1/2 times 1 plus sine of x divided by cosine of x. So that's first term, plus cosine of x divided by 1 plus sine of x. Make sure I got all the parentheses. Might need another parenthesis. So these parentheses match, those parentheses match, these match, those match, those match. This last one matches that one there. And I graph it. It looks like that, which is the secant function, which is what we're looking for. So that's the secant. It's a reciprocal of the cosine. So bingo. Use the trigonometric substitution to write the algebraic equation as a trigonometric function of theta, where theta is between 0 and 2 pi. Okay, so let's see what we're going to do here. So we're going to substitute x here into the square root. And then we're going to see if we can use anything to simplify this thing. So you get 64 minus 16 times x, which is cosine of theta, squared. Now, 2 squared is 4, so we get 16 times 4 times the cosine of theta, cosine squared of theta. But 16 times 4 is 64, so we get 64 times minus 64 times cosine squared of theta. We can factor out the 64. So it's the square root of 64 times 1 minus cosine squared of theta. I guess they're using x. Well, no, we're using theta. And the square root of 64 is 8. And 1 minus cosine squared is the sine squared. That's from the Pythagorean identity. The square root of the sine squared is the sine. So we get 8 sine theta. So use the trigonometric substitution to write the algebraic expression as a trigonometric function of theta. So as theta, where theta is between 0 and pi. Yeah. So that's what I'm doing. That's the answer, I'm pretty sure. I'm going to pause for just a second. Let me see if they want anything a little bit more than that. Okay, so that's what they're looking for. Okay, next one. 24. So again, we're going to substitute for x squared. We're going to put 2 secant of theta squared minus 4. So if you square that, you get 2 squared, which is 4. Secant squared of theta plus 4 minus 4. We can factor out the 4. 4 times secant squared theta minus 1. Square root of 4 is 2, so you get 2 times the secant squared of theta minus 1, but secant squared of theta minus 1. So we have to go back to that Pythagorean identity. 1 plus tangent squared theta equals secant squared theta. So if I move that over here, I'll get secant squared theta minus 1 is equal to tangent, so tangent squared, so I get 2 times the tangent squared of theta, but the square root of the tangent squared is the tangent. So I get the tangent, 2 times the tangent. Use a graphing utility to solve the equation for theta, where theta is between 0 and 2 pi. So we're going to do this in radians. So it just says use a graphing utility. So to do graphing utilities, to find the solutions, what you do is you take the equation and say that's equal to y, but you put everything on one side. So if you do that, you get the sine of theta minus the square root of 1 minus cosine squared theta. So I take this and move it to the other side. And the question is, when does y equal 0? So those are your x-intercepts. So all I have to do is plot this function and then look for the y-intercepts. And the function I'm plotting is the sine of, in this case, x minus the square root of 1 minus cosine 1 minus the cosine of x squared. So cosine squared of x is the cosine of x squared. So 1 squared of x minus sine of x minus the square root of 1 minus cosine squared of x. And let me make sure I got all the parentheses matched up here. I think I might have an extra parenthesis. Yeah, I got an extra parenthesis. Actually, I do need a parenthesis here, so where am I missing? No, I'm okay. So there you go. So what does that mean? So it looks like between 0 and let's change the view here to pi. So this is always true from 0 to pi, but it's not true between pi and 2 pi. So this is good from 0 to pi is valid, any value. And let's just try that. So let's say you take the sine of pi over 2, and then you take the square root of 1 minus the cosine of pi over 2 squared. Well, the sine of pi over 2, make sure I'm doing this right here, from 0 to pi, yeah, so pi over 2 should work. So the sine of pi over 2 is 0, and then we have the square root of 1 minus the cosine of pi over 2. Actually, the sine of pi over 2 is 1. 1 minus the cosine of pi over 2. So we get minus cosine of pi over 2 is 0, so you get that. So on the left hand side it's 1, you get the square root of 1, which is 1, so it checks. But if I did say 3 pi over 2, it's not going to work. So let's show you that. So if I take the sine of 3 pi over 2, and we have the square root of 1 minus the cosine of 3 pi over 2 quantity squared. So the sine of 3 pi over 2 is negative 1. Remember, here's the unit circle. The sine is the y-coordinate, so you can see the y-coordinate at 3 pi over 2 is negative 1. And you can see how it's not going to work because I get a negative sign here, but you can't get a square root of, you're going to get a positive number here. Well, I guess you could get it if it was plus or minus, but this doesn't have plus or minus, so you get 1 minus, well, the cosine of pi over 3 is 0. So what you get is negative 1 equals 1, which is not, can't happen. So that's what happens in the other parts of this solution. So here they're always, the signs are the same. Here the signs are opposite. So that one, why that one doesn't. And the same thing we can have here. So what we're going to do is we're going to plot y equals secant theta minus the square root of 1 plus tangent theta. And again, we're looking for where the function is 0, and that's the solutions. So let's plot that thing. So we get the secant of x minus the square root of 1 plus tangent of x. So we get a solution here at 0 and at, it looks like about pi over 4. And that's the only solutions that I see. Let's zoom out. Yeah, this thing goes wacko there. I don't think that's a solution. I think it's some kind of weirdness. So it's saying at pi over 0 and pi over 4 it works out. It gets you to 0. So you have the secant of 0 minus the square root of 1 plus tangent of 0. And the secant of 0 is 1. Cosine of 0 is 1, so the secant of 0 is 1. Then you have minus the square root of 1 plus the tangent of 0, which is 0. So you get 1 minus the square root of 1, which is going to be 0. So that does work. And the other was pi over 4. So let's try that. Secant, so y equals the secant of pi over 4 minus the square root of 1 plus the tangent of pi over 4. So the secant of pi over 4 is 1 over the cosine of pi over 4. The cosine of pi over 4 is square root of 2 over 2, so it's going to be 2 divided by the square root of 2. Then you have the square root of 1 plus the tangent of pi over 4 is 1. So we get 2 square root of 2 minus the square root of 2. But if we take the first term and multiply and divide by the square root of 2, we'll get 2 times the square root of 2 over 2. 2's cancel out. Here we've got minus the square root of 2 from there, so you end up with that, and you get the square root of 2 minus the square root of 2, which is 0. So that one does work as well. But if I tried any other things, it's not gonna work. Okay, the rate of change of the function f of x minus cosecant of x minus the sine of x is given by the expression cosecant x, cotangent x, and minus cosine of x. Show that this expression can also be written as the cosine of x cotangent squared of x. So this is true. The derivative, when you get to calculus, the derivative of the cosecant is negative cosecant of x, cotangent of x, and the derivative of the sine is the cosine. So I can verify that that is true. What they want us to do is to take the second part, the rate of change expression, and rewrite that as this product. So the thing I would do, I think, is I would rewrite these in their terms of sine and cosine. So cosecant is 1 over the sine. The cotangent is the cosine divided by the sine. We'll leave this second part the same. So that's the cosine of x over the sine squared of x minus the cosine of x. What we're going to do is we're going to probably multiply by the sine squared of x divided by the sine squared of x. So we can combine these two fractions. So we get the cosine of x minus the cosine of x times the sine squared of x divided by the sine squared of x. Now if I factor out the cosine, I'll get the cosine of x times 1 minus sine squared of x divided by the sine squared of x. And 1 minus the sine is the cosine, so I get the cosine of x times the cosine squared of x. This is from the Pythagorean identity. So I get that. But the cosine over the sine is the cotangent, so I get the cosine of x times the cotangent squared of x. And that's what we're looking for. So I converted this to the cosine over sine is cotangent, so cosine squared over sine squared is cotangent. Check. And that is all that she wrote.